Hey everyone, we are trying something different. I've been using OBS for recording my videos, but there's been some lag issues. So we are trying Zoom today. Hi, I'm down here. Oh, it's got me like reversed. That's weird. That's okay. We'll see how this works out. Hopefully it's better and we don't end up with the same lag that we had before. So we are doing week 4 strings and file IO. So this video will just be on strings, and then I have 2 other videos on file IO and exceptions. Okay, let's take a look. So the learning goals for this video include just those last 3 there. We're going to talk about different string functions that we can use in order to manipulate strings in really, really powerful and helpful ways. So just remember that strings are immutable. So what that means is that a lot of these string functions, when we call them, we actually need to return the new value and store it somewhere. So if you look at the first line here where it says string.out.println s.to lowercase, this would make a string s, whatever's in it, all lowercase letters. However, the variable s remains unchanged. It returned a changed value, but s itself is not any different. Whereas here, when I say s equals s.to lowercase, now s actually does change because we're storing it back in s. So we have to really remember that because strings are immutable, we can't just say s.to lowercase the way that with other objects, we've been able to just say .have birthday, and then it would change the object itself. That's not going to happen here because they're immutable. So we have to make sure that we return the value that we've changed to somewhere else, to anywhere else. Okay, so let's just do some practice for a second here. Let's just think about what we would want to do. So imagine for a second that we wanted to check to see if a string was a palindrome. And a palindrome is something that reads the same forward and backward. So we want to do this, and we're going to ignore anything that's not a letter, anything that's a space, and we're not going to care about case sensitivity. So we're not going to pay attention to periods and exclamation marks and question marks and commas and spaces. And a capital T is the same as a lowercase t, things like that. So we can see here that all 3 of these, believe it or not, are actually palindromes because they read the same forward and back when you take out all of that extra stuff. And so we have some methods here that we can use to help us actually do this. We have .replace, which will do a replace in a string. It'll search along the string for whatever you tell it to search for and do a replace with the new character. It will do a replace all, and it will replace anything matching that regular expression that we give it, which can be a string or it can be an actual regular expression with whatever you ask to replace it with. And s.trim will remove all leading and trailing white spaces on a string. S.trim does not remove white spaces for in between letters. One more here that's very, very helpful for us is to call index of on a string. And when we do that, we can go looking to see if a given string is inside another string. If it isn't found, it returns -1. But if it is found, it will return the index that it found it at. So for taco cat, for example, if we said taco cat.index of t, we would get 0 because the very first instance of the letter T is in the 0th spot. It's the first character. If we did taco cat.index of Z, we would get -1 because Z is not in there. The last one here is char at, which maybe you've seen before, and this one will return the character at a given spot. So if we say tacocat.char at 0, it will actually give us T. If we say tacocat.char at 1,000,000, it will give us an error. But using all these different methods, trim, replace all, char at, and index of, we can solve this problem. We actually don't need all of them to solve the problem, but there are different ways to solve them using these methods. So what we're going to do is we're going to flip over to some code and we're going to solve the problem. Feel free to take a pause on the video right now so that you have an opportunity to try this yourself before you see me do this example. Now, of course, the bar here is in the way. Did I write palindrome? Almost. I almost spelled it correctly. The zoom bar is right in my way, and I'm sure I can get rid of it, but I can't remember for the life of me how. Okay, let me see if I can figure it out. Hide floating meeting controls. Okay, did it. So now I can make sure I spell it properly. Okay, and now we can go ahead and add our main. And we're going to be really smart about how we do this. We'll make a string taco cat just to start, since this one is really simple for us. And we can see this is a palindrome, reads the same forward and backward. And then we will have a Boolean that says is palindrome. And it will call a method that will check for a palindrome passing in the string. So we're going to have our code nice and organized, just as we should. Public static Boolean, I can spell, check palindrome, and it takes in a string. So we know that a palindrome is a string that reads the same forwards and backwards, ignoring case and punctuation. Doesn't ignore numbers. It doesn't say that it ignores numbers. So if there was a number in there for some reason, I guess we'd have to count it, but we ignore case, we ignore punctuation, and spaces. Okay, so to start off, we just have a really simple example where there are no case sensitivity differences, there are no space differences, and there is no punctuation issue either. I'm going to add a print statement here that says stir actually, how do I want to do this? I will do palindrome status of the stir, and then we'll put this, and then we'll put is palindrome true or false, so that there's just going to be something to print. Okay, so what do we have to do? Well, we have to compare that the first and the last letter are the same, and then the second and the second letter and the second last letter are the same, and then the third and the third last letter are the same. So in a word like taco cat, where we have 1, 2, 3, 4, 5, 6, 7 letters, we have to compare letter at 0 and 6, and then letter at 1 and 5, and then letter at 2 and 4, and then, well, 3 and 3 is the same. Let's imagine this is for taco cat. Let's just think for a second if this had like an even number of letters, just to see what we would do to compare. We would need to compare 0 and 3. And we would need to compare 1 and 2, and then nothing else. And of course, if there's only one character, like when we hit O here in the middle of taco cat, it's a palindrome, right? Because there's only one letter. It does read the same forward and backward. So regardless if the string has a even number of characters or an odd number of characters, we actually don't need to check the middle character alone. It works out really nicely for us one way or another. So what we can see here is we're basically needing to break our string into 2 halves and then compare those 2 halves. Now, there's lots and lots of different ways to do this, but there's one really easy one, which is, as we can see, we just need to go through each character, and this one goes from the end through each character. So we're going to write that as a loop. We're going to go through each character up to the halfway mark, because this one runs for 7 characters. We're only going 3 times, right? 1, 2, 3 times. And for 4 characters, it goes 2 times. So we can say for the string that's coming in, dot length divided by 2. And the nifty thing here as well is that it's okay if s dot length divided by 2 comes back as a double. It's like no trouble at all. So for Anna, it comes back as 2, and that's fine. And of course, at some point, I will become 3, and 3 is not less than 2. But for taco cat, s dot length divided by 2 becomes 3.5. But that's okay, because the same thing will happen here, that as soon as we have 3, like 3 will still get checked against 3, but as soon as we hit 4, that won't exist anymore, and it will be fine with it. So we don't actually have to worry about the fact that this might not return a whole number. You can worry about it. You can cast it if you want to, if you have concerns, but it's actually okay either way. Okay. So then we can go ahead and we can do this. And now we're going to get, I'm going to do this in lots of steps. We're going to get the first character to compare. I don't want to call it first character. I'll get char1, which we know is the very first character the first time it runs, the second time it runs, the third time it runs. Well, that just equates right up to I. So we can just say s.char at I, and we will get the character that we want. Then for the second character, when the string is seven characters long, we need it to be 6, then 5, then 4. And when it's 4 characters long, we need to start at 3, then 2, then 1. So we know we're going to need to get char at least s dot length minus 1, because when s is 7, minus 1 will give us that 6. And when s is 4, then 4 minus 1 gives us that 3. But we need that to also go down by 1 each time our loop runs, right? 6, 5, 4 for Anna, 3, 2, etc. So we also want to actually subtract I off. That's what that math looks like there. Is each time you also take off I, and you end up with like the length minus 0 minus 6. Sorry, the length minus 0 minus 1 would give us the 6 for this one. The length minus, in this case, 1 minus 1 gives us the 5. The length minus 1 minus I gives us the 4. And then for Anna, gotta move all this over, sorry. We'd be doing 4 minus the 1 minus the 0 gives us the 3. And then 4 minus the 1 here minus the 1, this extra like 1, and then I is equal to 1, will give us the 2. So we can see how that equates to each other. Okay. So we can see now how we get these 2 characters every single time throughout this loop. Now, since we're going to have to be returning a Boolean, I'm going to make a Boolean result, and it starts off as being equal to true. Because if we can make it through this whole list here with these always being equal to each other, then that does mean that this is a palindrome. So we can just return our result. But at some point, if char1 does not equal char2, we have to be able to say, oh, our result is false. They aren't actually a palindrome. I from front and I from back are not equal. So it won't be a palindrome if it gets inside here. Now, it's possible that our code could run for a really long time and not need to if like the very first scenario, like the first and last letters aren't the same. We already know that it's not a palindrome. So something we can do is we can update this condition right here of our for loop that'll say for int I is equal to 0, I is less than the length divided by 2, and we don't yet have the result figured out, right? So we can just include that just like you would in a while loop, and that's totally cool. And now this for loop will break out if result changes or if we fall off the end of the list. This is sometimes standard. You could also have just made this into a while loop and then declared the I variable somewhere else. That's probably more standard, but either or is really okay. So cool. So now what happens when we run this? Let's open up my terminal here and let's go run the code. Palindrome example. Okay, palindrome status of taco cat is true. And let's just make sure that something that we know isn't a palindrome, just like taco, this should probably return false. So let's just make sure. Okay, that didn't return false. Is palindrome. Why didn't that return? Oh, it didn't save. It didn't save. Okay, way to stress me out. Put that back. Errors up the wazoo here. Okay, there we go. No, it still says true, but it definitely shouldn't. So something's wrong with our logic. And I bet all of you see it already, and I can't see it because I can't see all of you. Let's see if I can figure it out though. Hey, let's see. Let's look at what these 2 characters are to see if we can figure out why my code isn't working the way I would expect it to. You're at home and you can already see what I did wrong. That's pretty awesome. Okay, this is not like recompiling because it didn't even do this. Something weird is happening with this, that it's not actually recompiling. Let me just go and throw out this old one. I'm not sure why it wouldn't just properly recompile. But not calling this method, check palindrome, should be right in here. S. recompile, palindrome example. Okay, it did that. So it's not actually going into my loop for this one for some reason. So since these weren't printing, but the other one was, I can tell it didn't even go in here. So this must be wrong. Let's take a look and see what this is. Oh, this is coming back as 2, which is correct. Oh, haha, I know what's going on here. I'm so silly. Okay, I did figure it out. This needs to just say end result. This would have helped if I gave this a better name. Let's fix that right now. So is palindrome. So keep going through the loop while there's characters to check and it's still a palindrome. Then if at any point we realize it's not a palindrome, we'll break out of the loop and we can return it. Okay, so remember when I said 2 minutes ago, oh, I should give this a better name than result. Yeah, this is why. Okay, so now it's coming back for taco as false. And if we make this taco cat, let's make sure that this is coming back as true. Fantastic. Okay, so now we have the basics of this working. We're now going to go ahead and we're going to add in the other layers that we told ourselves we had to consider. We have to make sure we ignore cases, spaces, and punctuation. So let's start by adding a capital letter and see that this is about to fail. So if I try to compare these, it's coming back as false when it should be coming back as true. And there's a really easy way to watch for this, which is to just make sure everything is in the same case in here. So here's what we'll do. We'll just turn this into original string up here. And we'll say string s is equal to the original string dot to uppercase. So now everything is going to be turned uppercase in the variable s to allow for everything for sure to be all in the same case. If it's already uppercase, it stays uppercase. If it's lowercase, it gets turned into uppercase. And now taco cat comes back as true appropriately. Fantastic. Let's add some spaces. Let's add a space just to the front, actually, because that's all we should be worrying about. Now, there's ways to ignore the space, like checking for spaces, and if it's a space, you just don't do anything and things like that. But that can make this way trickier to code when there's actually a really easy way to do it. So, of course, with the space, it's now coming back as false. And if we know that we're going to have spaces at the front or at the back, potentially, we can use s.trim, just like we said. If we think we might have spaces throughout the string, we can use s.replace or s.replace all. There's a nifty little regular expression there that means for any number of spaces. So that actually would work for the front spaces too. You can just do it like this. And this will work for any number of spaces. So this works for 1 space, 2 spaces, tabs, etc. If I instead would have just done this, that's only 1 space. Or this, that's 2 spaces. So it would only find those cases. But we can do this and it will find all cases. 1 space in this scenario also would potentially work because every tab is just made up of lots of spaces. But there are some scenarios where you'd want to know, especially soon, you're going to want to know this little regular expression here, //s plus means 1 or more spaces. Okay, so now let's give this a try. Let's clear. Let's, you know what, I really want to put this in its own panel just to make our lives easier to see everything. Okay. So s.replace all didn't like my regular expression. Is it backslashes? I don't think so. I can never remember. Let's just do it with a regular space since we're just having it up at the front anyway. Javec.star. There we go. We pulled out that space. Comes back as true. Let's just see if I add additional spaces into taco cat. Random additional spaces. And I recompile and rerun that. Oh, it still says true. Good. Okay, so a single space works there. And we're going to use that regular expression in 1 to 2 videos. 1 video. We'll do it in the next video. Okay, awesome. So now we're taking care of strings that have spaces in them, that ignore cases. And the other thing we need to make sure we ignore is punctuation. This one can be a little bit trickier, but we definitely can use replace all for this one. So we can do let's do it in separate steps. Let's just do it with replace. Like, let's say we're looking for exclamation marks and we're going to replace that with an empty string. You can do this as a regular expression in replace all, but just so that we can see each one of them being separated out like this. If you just put them all on one like this in a dot replace, it won't work because it will look for all of them like in sequence. You have to do them separately if you're using dot replace like I'm showing here, which means that now when I add things in between all the different letters, exclamation mark, this should still be Taco Cat with everything removed at the end. So it still comes back as true, even though it looks kind of cuckoo over here. So now we can change it to nurse runs, and we can see that that's going to work. Nurse, what did I do wrong? Nurse run, right? Nurses run. I just don't know what the actual thing is. There we go. That is the nurses forward and backwards. I just don't know what palindromes are, apparently. There we go. So we can see how we can sort of just build up on our program until we've reached a place that has over here that takes care of all the cases that we had concerns about. Cool. So let's look at some other string methods, some that we will probably use shortly. So we've already seen concatenation where we're just like taking two strings and adding them together, like we have hello plus world and they all come together. Compare to is a really, and we've seen dot equals or dot equals ignore case already. And that one checks for two strings that are equals, but we also want to have a way to figure out like which would come first in a dictionary. So like alphabetical order. So we have dot compare to. So we call dot compare to on two strings. So like s dot compare to other s, other string. And it will actually return an integer. It returns a number that will either be a negative value, 0, or a positive value. And the dot compare to method for strings does some fancy math using numeric codes to figure out which word comes first in dictionary order. So if you get a negative number, then the string 1 in this example, like this one, comes first for a negative number. Nope. If you get a positive number, this comes first. And if you get a negative number, this comes first. But also make sure that you know that if you wanted it to be case insensitive, you have to put them all in the same case because otherwise there is a difference. They will actually be different. If you go and Google like an ASCII or Unicode table, you'll be able to see the numeric values for the different characters, and you'll understand why uppercase is being like stated as less than lowercase. The other one here is substring. So substring can always be tricky, but it basically allows us to like splice a piece of a string out. So like if you had the word world from above and you just want to pull the O out and leave behind WRLD, we can do that using substring. So you would pass the string in, you'd say string1 dot substring, and then you pass in the character that you want to start at and the character you want to end at. So for if we were just trying to pull like the world, the O out, you would do character, well, W is 0 and O is 1. So your starting character would be 1. And then you want it to stop at character 2. The way it works is the splice will happen starting at the first position and will go up to, but not including the last position. So from positions 1 to 2 will only get you that first character. Which is, or sorry, just like we'll get you just the one character, I mean, which is very helpful since this way, you know, you don't have to worry about things like putting -1 on it. If you're trying to go to the end of your string, you can just say from 0 to like dot length, and it will take care of it for you, which is very helpful. I'm curious if I can like flip my camera because it's driving me cuckoo. Not like that. It literally says mirror video and it's disabled. That's so annoying. Okay, I guess not. Whatever. I was just looking at the settings. Sorry. So, okay, so you can pass in a starting character, like a starting index and an ending index, and all together it will come out from starting up to, but not including the ending position that you specify. If you only specify one position, so let's say you only specified one, so you would say string one dot substring one, it would grab from the character you specified all the way to the end of the string. So in the case of world dot substring, and then in the brackets you put a one, you would get ORLD, and the W would be cut off. So you'd end up with what you want. So if you just want to pull out the O, you can say 1, 2. That will pull out the O. I think maybe what I said before might have been confusing because it sounded like you could like cut and join around the O. But in order to do that, I'll show in a second. But to splice things out, you can use substring. So let's just see what that looks like in another file here. Public class substring example, substring example.java main. Okay, so if we have string s is equal to world, we'll just do it all up in here and we print out s, we'll just get the printing of the word world. So we'll just run that really quickly. Java substring example, just world comes out, which we expect. So now let's look at what these different substrings can give us. So if we say s.substring from 1 to 2, we're going to get that single character of O as we expect. It does return a string, so it will return it like this, not as a character. Like it will return it as double quotes string. You can't just like shove it into a char variable without doing a little bit more manipulation to it. Let's just see what this prints out. So there's our O. If we wanted to do it where we could grab it from O to the end, so we just want to take the first character off, we can do this, and then that will give us world. Let's run that. There we go. And let's pull the O out. And let's do it without knowing where the O is. Pull O out of string. So the first thing that we would do is we would find the position of the O in the string. So we would say index of O to find the position of it. And as long as the position was greater than or equal to 0, right? So as long as the position exists, because if it doesn't exist, it will return -1. As long as the position exists, we're going to go s.substring from 0 up to the position. And then we're going to add on the substring from position +1 all the way up to the end. Now notice that what this means is position does not get included. We'll go from 0 up to, but not including 1 in this case. And then next time the other half of it starts at 2. So 1 actually gets fully cut out, and this will land us with world with no O. Okay, there we go. So there's all of our different examples of using substring in different ways. Really quickly, I'll show what happens. So I'll show two things really quickly. You can do a substring from like 0 to 0, but it will just get nothing. Just nothing, because you can't grab any characters. So it's no trouble if you accidentally end up, like if my position here was 0, if O was the first character, this would have just grabbed nothing, and then this would have grabbed everything but the first character. So that's not a problem if that happens. You can also say s.length -1 to get the s.length like this. Let's do everything but the last character. So we have to do it like that. We say 0 to s.length -1. If you just say s.length, it would have given us the last character, right? Because the length of the string and the positions of the string are not the same. And lastly, let's just make a quick attempt at doing a substring on a number we know doesn't exist in our string. It will compile because it won't realize it until after compilation, but we do end up with this massive error right here. String index out of bounds exception, range 1000, comma 5. Look, it's even using math notation. So it's saying the range starting at 1000 and going up to, but not including 5, is out of bounds for length 5. So because I only specified a single value here, this automatically became 5, and it's saying, oh, that's out of bounds. You can't do that. Even if I tried to specify both ends, because those values are both outside of it, the answer will be the same, but the range it shows will be different. So if we take a look, we can see right here, the range is now showing from 1000 to 10,002, exclusive on that side, is out of bounds for length 5. So it's just two slightly different error messages because one, I didn't specify the endpoint, and one I did. Okay, so that's substring. Oh, here it is. I thought it was in the next video, but here's our string. I did have the slashes backwards. Check me out. Okay, so this is one of the more helpful string methods that you're definitely going to find yourself using when doing file I/O. The dot split method. And what the dot split method will do is it will take a string and it will split that array into elements based on whatever you pass in. So just like when you were doing a replace and you would replace something on a space, every time it found a space, it replaced it. Here, rather than replacing it, it turns it into an element and puts it into a string. So let's give this a quick test to see what happens. Let's make one more new file so that I can upload all of these nicely. Split example. Oh my God. Split example.java. Okay, and we are going to make our main. And let's start with a string that just says, hello world, just like that. We can print it out. We'll show that that's the string. Then we're going to make a string array. And typically we call our string array tokens because each of the elements that gets sort of split out of our original string is typically referred to as a token. That's just weird language from, I don't know, from days of old, perhaps. It doesn't have to be called tokens, right? It's just a variable name. You can do whatever you want. Depending on what you're reading in, it might make more sense to give it another name, but the typical name that you're going to see in my notes in examples will be tokens. So we say s.split, and let's start by just splitting on a space like this. So not using that fancy regular expression, just splitting it like that. And then we will need a loop. Let's do a for each loop. For each token in our tokens array, notice this one has an S, this one doesn't have an S. So for each token in the tokens array, let's just, we'll print them all on the same line. Print the token with a space. Right before it, we'll print a bracket, and then right after it, we'll print another bracket. All right, this is getting long. Let's clear this. Let's compile that file. Compile that file. Oh, I think I need that on a hat or something. Oops, I put a star in there. This shouldn't be there. Compile that file. Okay, so that compiled fine. And now let's run it. Oh, this should have been on the same line. I need to fix that, but that's fine. We can see that we ended up with like both words. Something I didn't think about though was the fact that it will be very difficult to see that these are two separate tokens unless I put them on different lines. So let's put them on two different lines. There we go. So here's our original string, and then here are each of the tokens printing out. So they got separated on the individual space. If we add more, we'll end up with more things. Hello world, comma, my name is Lauren. There we go. We're going to go ahead and compile that and run that, and we can see it's split on the spaces again. We didn't split on the comma, so the comma stays attached to world. And if you were getting data from like some unknown source or something, it would be your responsibility to now figure that out and figure out what you're going to do with the fact that you know that there might be punctuation still stuck in there. But typically, we tell you for the assignments in this class what to expect when it comes to parsing strings like this into tokens or tokenizing strings. Let's just see what happens if I add extra spaces or if I add a tab. Or even if I add maybe a backslash n might work too. So my original string, I better put some space between my original string since I have a new line in there now, and my not original string, what I'm hoping to be separate, just so that we can see it. So we can compile and run it, but what we're going to see is here's my initial original string, hello, my name is Lauren. But here we ended up with a hello string, an empty element, an empty element, an empty element, world. This never got pulled out at all for some reason. And then my name is Lauren. Those were each individually pulled out correctly. But world and my, for some reason, didn't get separated out. Yeah, things got kooky. Oh yeah, because there was the tab there, right? Things got kooky, and that's because dot split right now is splitting on single spaces. And so when there was more than just a single space, it got confused. So like it split this single space, and then this got printed, and then it split this this single space. There's 4 spaces in there. So like it split hello, then took this out, then there was an empty element, then it took this out, then there was world, comma, backslash T is being sent in as a tab, not as spaces. So world, comma, tab, my is all one element, then a space, then name, and then our new line, and then is and Lauren were caught. Okay, so how can we fix this? Now is when we actually want to make sure that we use the backslash s plus regular expression, which says all split on all the spacing, all of it, any kind of spacing split on it. So when we run it with that expression instead, what we see is actually the exact same thing as before when we only had single spaces. So it's more typical for you to want to split on like either all the spaces or on commas or on O's or whatever it might be. Let's mix this up a little bit here. Let's do something like ABC, 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 QRT, BA, S, AB, and we try to split on ABs. I better put one more letter at the end there. So if we want to split on ABs, we're going to end up with AB getting split so that we have a C. Then we're going to have AB, we're going to have a C, AB, and then CQRTB, CQRTB, AS, because nowhere in there did we have AB in the order of AB. Then we have AB, and then we have our Z. So I should see 4 separate things at the end of this if I did my reading correctly. You never know. That's exactly what we got. Sick. Great job, me. Okay, so that we can really split on anything is the point there. This is the split one. Okay. So at this point, I'm going to ask that you pause your video. Of course, I'm not pausing right now. I'm going to move on to the next video, but pause before you go forward to the next one and try these 2 different practice problems. Try writing a function that would validate an email address with the expected email address form of some information with no spaces, at, and then some like however many dots come after with each of those parts. Write a function that will make sure that there's one @ sign, that after the last period, there's no more than 3 characters, that there's no spaces in here. You can have spaces in an email address, and returns true or false based on if it's a valid email or not. And then also do one for validating a phone number. So here's an example of a phone number, 204-555-1111. You can assume that each part is going to be separated by dashes. Just to make your life easier when it comes to writing and practicing right now. So you'll write some kind of a function that ensures that in total, there are only 10 numbers, that they're all numbers, max. You can write it so that it's possible that somebody would forget to include the area code. So maybe they just enter 555-1111. If there is an area code, there should be 10 numbers in total, 3 of them after the first dash, 3 after the second, 4 at the end. If there's no area code, there should be 3 values and then 4 values, so 7 numbers in total. It's another fun problem to practice your conditionals and your string manipulation with. And then once you feel good about that, you can move on to learning all about inputting and reading and writing file stuff. And exceptions. We're doing exceptions too. Thanks.